Alhamdulillah, assalatu wassalamu ala rasulillah. Assalamu alaikum wa rahmatullahi wa barakatuh. One of the toughest topics to be considered in physics is charge distributions and electric field due to charge distributions. Today we are going to discuss charge distributions and their electric fields around them at a certain point, and that field can be calculated by following certain steps, specific steps. And if we understand these steps, and this is just a procedure, and if we understand this procedure, then we can easily calculate electric field due to any kind of charge distributions. But let me explain briefly what are charge distributions. There are two types of charge distributions: charge distributions. One of the charge distribution is random. What random means? Random means if you have an object, suppose this a sheet, there is a charge plus, there is two charges, there is one charge. This is not uniformly distributed throughout. That means in some area there is more charge and in some area there is less charge. This kind of distribution is known as random charge distribution. And there is another kind of distribution which is known as uniform or uniformly charged distribution. What it means, suppose you have a same sheet. In this, if you observe, you will find charges throughout the whole surface uniform. That is, in any particular region or area, there is equal amount of charge present if the areas are equal. This kind of distribution is known as uniform charge distribution. This uniform charge distribution could be further divided or subcategorized into three categories. One is known as linear charge distribution. What it means? It means that there is a thin or there is a line, and in this line there is charge distributed throughout the length. Second is surface charge density. And what is surface charge density? In a given surface there is uniformly distributed charge. And another is volume charge distribution. Suppose this is a sphere, and on this sphere there are charges distributed uniformly throughout the volume. In each case, we can assume that Q charge is distributed throughout the length L, and in this we can say charge Q is distributed throughout the area A of the surface. And in the third case, charge Q is uniformly distributed throughout the volume V of the sphere or any solid. And we define a quantity Q by L in this first case. What it means? It means if we select a unit length, say 1 meter or 1 centimeter, then in that unit length amount of charge present is Q by L, and this is denoted by lambda, and it we call linear charge density. Linear charge density. In the similar manner, we can say charge Q is uniformly distributed throughout area A. So we say this charge Q is uniformly distributed in the area A. If we take unit area, then what is the amount of charge present in that unit area? That is Q by A, and this is known as surface charge density. Surface charge density. So here we can write it surface charge density. And what about that solid? Here the similar concept, Q divided by V. What this says? It says that in total volume B, charge Q is uniformly distributed, and Q by V gives amount of charge present in unit volume. and this is represented by the letter rho, and this quantity is known as volume charge density. Volume charge density. So if we have a uniform charge distribution, it may fall into one of the three cases. If there is only a length, that is, it has no width, no thickness, only a length L, in this case the charge density is known as linear charge density, Q divided by L. If we have a area, thin area, that is, it has only two dimensions, length and width, it has no thickness, then this quantity Q by A gives us surface charge density, and in this case we have three dimensions, length, width and height, and in this case we have a volume charge density given by Q by V. Obviously, for different charge distributions we have different units. For example, here we can see in numerator there is charge, and unit of charge is coulomb, and unit of length is meter. Therefore, it will have a unit of coulomb per meter. In similar way, we can calculate the unit of surface charge density, coulomb meter square per meter square, and here coulomb per meter cube. If we understand these charge distributions, then we can move or proceed to calculate electric field created by these charge distributions at different points.